it's 10:30. I'm gonna get started here. Are there any questions about the topics that we have talked about so far? Conditions? Yep, go ahead.
Oh, yeah. I actually got some help this morning, but if you could go over the pre-increment, post-increment, or
Okay.
just, I didn't quite understand it, the way it was written in your notes. I had trouble.
Okay, with pre and post increment? Okay.
Yeah, like the example was like x equals 34, x plus plus,
Mm-hmm.
plus x plus equals x. Like I said, I did get help with it this morning, and
Mm-hmm.
didn't finish the review. I'm just going to try to get
I think that quiz is still open, right?
right.
Yeah. So if it's still open, I can't really talk about, the exact same thing, in the quiz. But instead, what I can do is to, like use sample programs in this class. I can illustrate some of those concepts. So let's go ahead and use some, sample programs. And we'll just go to this folder here and write a program for increment and decrement, pre-increment and decrement stuff. So we'll just call that inc.cpp, increment.cpp. Okay. So we'll just go ahead and use the debugger, GDB, to illustrate these concepts. Because the range of numbers that I'm working with is relatively small, so I'm not going to use, like en32_t, because it's going to be like a small number to begin with. So I know for sure that these numbers can be represented using even 8 bits. So I'm not going to specify the width. So in this case, we'll just have, let's say, two, local variables x and y. And then we'll go ahead and do some code with it. Okay, so we'll say x starts with a particular value. Okay, say 91. Okay, and now we want to change x. So we want to change x using using one of the two increment, either pre or post. So what we'll do is we'll start with pre. Okay, the pre-increment is the easier one to understand, because with the pre-increment, what it means is you're incrementing first, and then you are using the value of the variable after the increment as the value of the expression itself. Okay, so in this case, if I say y equals plus x, then it is really doing the same thing. I'm using comment here to basically say it is the same thing as the follows. Okay, so this one is really saying the same thing as x gets x plus 1, and then we say y equals x. It's the same thing. Okay, and yes, I use a comma here instead of a semicolon here, because I'm using two expressions, into one comma-separated expression. But it's basically doing exactly the same thing. So that means y should end up with a value of what? 92. Yep. Okay. So now, if I go back and say that x equals to y plus plus, this time, I'm using post increment, which basically means I'm referring to the value of y first. Okay, that becomes the value of the expression, and then I go ahead and add 1 to y. But by the time I add 1 to y, I have already determined the value of the expression. So the new value of y has nothing to do with the value of the expression. It's the old value of y that is a part of the expression. Okay, so let's go ahead and see what this means. So if I have to break this down into its components, it is basically just do the assignment first, and then y gets y plus 1. And that's why it's called post increment, because I refer to the value of y first, and then we go ahead and change the value of y. Is that okay? So according to this, what should be the value of x on the last statement, after the last statement?
91.
92. Because y itself is already 92, and I'm using y plus plus to update x. So basically, x should not see any changes. Yep.
So in this case, like the last thing, y equals y plus 1 is going to be y equals 93 then?
Y will become 93 after that. Yes, that is correct. Yep.
Okay.
Well, don't take my words for it, right? I'm not sure about your other professors nor politicians, but you never trust tech. Yeah, not that I'm trying to lie to you, but sometimes I just give you wrong information. So you always want to kind of keep an eye on that and just say, okay, I want some confirmation. How do I confirm this is the way the program is supposed to work? Now, unlike politics or some other types of stuff where things can be discussed and there are different ways of looking at things, there are different shades of gray, in programming, there's no such thing, right? Either it works the way it's supposed to or not. Okay, I like things like that. Okay, black and white. So we'll do it. We'll test it. Okay, it's easy enough to test it. So we say G++. We want to compile the program, but we also want to make sure that we include debug information here. And if you want to turn on warn all and then tick, to make it warn just about everything here, then we'll go ahead and specify all of these things. -O inc to specify the output executable is named inc itself, and the input is the source file inc.cpp, and it comes back without a single warning, okay, which is good. If it did, I would fix it first. Then we use GDB to look at the execution of this program. First thing is to do a list to look at the content or to look at the listing itself. And we'll put a breakpoint on line 6. Okay, line 6 is the first line that starts to become interesting. So we'll run the program. Now it has stopped on line 6. What that means is we are about to execute the statement on line 6. It has not executed yet, but we have executed everything up to, but excluding line 6. So that means line 5 should have executed already. So if I say print x, it has a value of 91. Any questions at this point? Okay, pretty much predictable stuff, right? So now I'm about to single step line 6. So I say single step. Unfortunately, it cannot evaluate the right hand side and then stop and then let you finish up the entire thing, and then stop again. So when I single step on line 6, it is basically going everything on line 6. But we can now check to see what is the value of x and what is the value of y. What do you think should be the value of x? No. We are done with line 6 already. On line 5, x already has a value of 91. And then on line 6, the first thing I do is to increment the value of x. So x should have a value of 92. What about the value of y? Also 92, because we are updating the value of y after we update the value of x. So since the value of x became 92 first, and then we use that value to update y should also have a value of 92. So let's check first. X has a value of 92. Y also has a value of 92. Okay, so far so good. We are now about to execute line 7. Okay, so we single step through line 7, and now we want to say, okay, what should be the value of x and what should be the value of y? According to my explanation, the first thing it does is to go through and say, okay, use the old value of y for whatever, and then we change the value of y. Y had the value of 92, so x should still be 92, because x was 92 from the previous line. I'm just updating 92 to 92, so x should still be 92. So we say print x has a value of 92, just as expected. What about the value of y? 93. And that's exactly what it is. All right. So is that kind of helping you understand the concept of pre and post increment?
Yes, thank you.
Okay, very good. And decrement is the same way, except it's instead of adding 1, you're subtracting 1. All right. Any other questions before we move on? No other questions? All right. So if there are no questions about increment and decrement, pre or post, we are now going to move on to, we talked about conditional statements already, and remember last time we kind of made a big mess, okay? And I recommended, how to write, control structures, which is basically always use open curly brace and close curly brace, even though you only have one thing to specify or nothing to specify. Okay, because having an open curly brace with nothing inside and then closed curly brace doesn't really slow down your program. It might look a little bit longer, but it does give you, quote unquote, the structure so that you can easily insert additional statements later on without having to worry about, well, what I'm adding here, is it really a part of this conditional statement or is it outside of this conditional statement? Okay, so that's something that we talked about last time. I'm not going to go back to revisit that unless there's a question. So what we'll do today is to kind of continue to talk about loops. Okay, we'll talk about pre-checking loops, post-checking loops, and then the for loop, which is basically a shorthand version of a pre-checking loop. So we'll start with this particular one first, and it is a pre-checking loop. It's also called a while loop. I usually call this a pre-checking loop because when you say it's a while loop in C and C++, it is a little bit ambiguous because the post condition loop, the post checking loop is also a while loop, except it's do while. Okay, but the word while is in both versions of the loops. So in this case, I call this a pre-checking loop because it checks the condition first. The syntax of a while loop is pretty simple. You start with the keyword while. Okay, you have to spell it out the way it is spelled out here. Open parenthesis. Every time you specify a condition in a control structure, you always need parentheses around the condition itself. You put the Boolean expression here, but remember in C and C++ we don't really have Boolean expressions, so this expression is just something that returns a 0 or a non-zero. A 0 is interpreted as false, a non-zero is interpreted as true. That's all it is. And then we have the close parenthesis here. And then you have one single statement after the close parenthesis to specify what you want to do when the expression is true. Okay? It's kind of like a conditional statement from that perspective. The difference is, what do you do after this statement executes? With a conditional statement, you get out. Okay? You continue execution with whatever is after this. But with a loop here, once you're done with the statement of a loop, you go back and you reevaluate the condition. So you basically evaluate the condition. If the condition is true, you perform whatever you specify after that, and then after you perform whatever is after that, you go back and check the condition, and if it is true, you continue with the statement after that, and you keep doing this until the condition becomes false. Then you get out of the loop and you continue with whatever is after the loop. Is that part okay? That should be consistent with your understanding of how loops work from the previous class in cisp 300, 301, and 370. Okay. So we'll go ahead and just write a little loop here, and basically just to see how it works. But before that, we'll just go ahead and read this little paragraph here. In general, the condition of a loop should mention at least one of the variables affected by the body of the loop. Let's just kind of look at this statement here. It is not the syntax of C that is enforcing this rule. It's just that it makes sense in most situations. Not all, but in most. So in most situations, let's say your condition is while x is less than y. Okay, do, and then in the blocks here you specify some code. That code that you specify after the while, which is the statement to execute again and again, should involve at least one of those two variables. Is that making any sense? Because if the body of the loop or the statement of the loop has nothing, absolutely nothing to do with the variables involved in the expression, if the condition is true to begin with, how can it become false? Right? Now, I only said in most situations because in certain types of situations, which is not something that you guys have to worry about, there are things in the quote-unquote background of a program that can change the values of variables. Okay, they're called interrupts. You can also signals. Okay, in the case of Unix type of programming, but it's not something that you have to worry about in this class. So I would say in this class, if you have certain variables mentioned in the expression of a loop, somewhere in the statement in the loop, you have to be able to change at least one of those variables. Okay, and someone's gonna say, well, but I can use what if it's a global variable? I can call a subroutine that can change that global variable, so I'm not actually explicitly changing that variable inside the body of a loop. Right? Is that making any sense? That's exactly why we don't like global variables. Okay, so repeat after me. Global variables are evil. That is funny. They're really, really bad because it's a very easy way to patch a problem. Okay, so when you are just using it as a patch, it's very easy to apply. The problem is, if you keep using global variables, see how evil they are, global variables to patch a program. After a while, your program will have a lot of global variables, basically quote unquote floating around. The problem is, when you invoke a subroutine, when you call a subroutine, it is not clear which global variable a subroutine may or may not affect. Okay, if you always use parameters, and say that okay, this subroutine may change this thing, okay, then it is spelled out. It is clear to you that this subroutine may change, that particular variable, and that's okay, not a problem. It's only when it is not clear that it is an issue. Okay, I have written, I have maintained, okay, unfortunately maintained programs that use like hundreds of global variables to reflect this type of status, that type of status, and whatnot. And I can tell you, as a developer, those programs are very, very, very difficult to maintain. It's just that you never know. Okay, you call a subroutine, you don't know whether it's going to change a global variable or not. But tag is so easy. Just go into that subroutine and check it. But what about those 20 other subroutines that this subroutine calls? I have to track those down too, right? So you have to track down every single one all the way through the entire call tree, which is the order of calling subroutines, and make sure that no one is going to change a particular global variable to be safe. And that's a lot of work. Okay, it's not worth it. So don't use global variables unless you really, really have to use it. Yep.
Are you recording already?
Yes, I think I am. Yep. And double checking the. Yep, it's right. It's recording, and it's also recording the audio. Because occasionally I will be recording the screen, but without recording the audio. Okay. All right. And also keep in mind that in the while loop, or what we call a pre-checking loop, the condition is checked first. So that means there are two things as a consequence. One, it is possible for a while loop not to perform a single iteration if the condition evaluates to false to begin with. Okay, you can say while a certain expression statement. Okay, that statement may not execute even once if the condition evaluates to false to begin with. So keep that in mind. And secondly, variables involved in a condition should have defined values before the first iteration. Otherwise, you'll be evaluating something with an undetermined value. And all of these things that I talk about here, the issues that you need to be aware of when you deal with a while loop, they are not syntax issues. Okay, the compiler cannot check these things for you. Okay, these things are basically related to how you utilize variables and expressions in the context of a while loop. So are there any questions about while loops? Any questions? All right. If there are no questions about while loops, we move on to post-checking loops, which is a do-while loop in C. So in C++, a post-checking loop comes in the form of a do-while loop. So this is a little bit different from the way I teach it in cisp360, which is a repeat until loop. Okay, in a repeat until loop, the condition specifies the exit condition. In other words, it tells you when we are getting out of a loop. In a do while, the condition tells you when we are staying in the loop. Okay, which is the exact opposite of an exit condition. So the general syntax of a do while loop is the word do, followed by whatever statement that you want to perform as a part of the iteration, and the word while, and an open parenthesis, some kind of Boolean expression, so evaluates to either 0 or non-zero, and a close parenthesis here. This semicolon is only here because it is the end of a statement. Okay, now when you look at this statement here, this condition, if it is true by the time it evaluates, then we go back to the beginning and then we perform whatever statement is between the do and the while. One more time, we get to here, then we reevaluate the expression. So we keep doing this until expression evaluates to false, to 0. Then we get out of the loop. Are there any questions about how a do while loop works? Questions? Yep, go ahead.
I have a similar question not about do while, but do we have do until in C++?
Sorry?
Do we have do until in C++?
Not technically.
Not technically.
Well, C leaves you, or C, C++, they're basically the same language for most practical considerations. It's flexible enough that you can define what we call macros.
You make it up.
So you can make it so that it looks like that, but it's not the same thing. So if you ask me, is it a part of the language itself? No. Do until is not a part of the language. But if you ask me, can we make it a part of can we use it? Then the answer is yes, if you define macros in a certain way. But we haven't talked about macros yet, so the answer is basically no. We do not have do until, which is just a flip of the condition. Yep.
I think I missed it when you said in a pre-checking while loop, if it's true you continue, if it's false you get out.
Mm-hmm.
In a do while loop, it's the reverse.
No, it's the same. If it's true, you stay in the loop. If it is false, you get out of the loop. So the condition is, in both cases, the condition, if it is true, you stay in the loop. The only change is, with a while loop, you check the condition first. With a do while loop, you check the condition after you perform the operation. All right. So let's go. Yeah, go ahead.
So no matter what, it's always going to perform that first iteration, right?
With a do while, yes.
Yes.
But with a while do, it may not perform even a single iteration. Okay? So let's go ahead and illustrate some of those concepts that we just talked about a little bit earlier. Things that is kind of interesting with loops. Okay? So we'll go ahead and write another test program. In fact, we'll write a few. Okay? So we'll go ahead and write while one. Okay? This is one to illustrate certain things about the while loop. Everything starts with the main subroutine, so we need that here. Okay, so we'll start with something that is kind of very typical of something that you would see in a C program. So we'll say while x is less than 5, okay? And then the body of the loop, in this case, I always use a block statement as a statement in the loop. You don't have to, okay? If you only got one single thing to do, you don't need to open curly brace or the close curly brace. But remember, if you don't, then later on, if you want to add some more to it, and you just kind of append another statement after the first one, the second statement is not a part of the while loop. Okay, to avoid that problem, I always use open and close curly brace so that I know, okay, whenever I insert something, it is still a part of the loop. It is visually clear. There's no way I can make that mistake. So in this case, there's only one thing I want to do here, and I'm going to use the long form here, x gets x plus 1, and then we have return 0 at the end. Okay, this is a pretty simple loop here. But the first question I have is, what is the value of x by the time I get to return 0? Just by looking at the code here, can you tell me what is the value of x when I get to the return statement?
5.
It's exactly 5. Okay, that's correct. Because x equals to 5, would make x is less than 5 false, and then we'll get out of here. Okay, so this program is very, very typical of how you use a while loop in C. So we'll say C G++ -G -O while 1 -1 all -pedantic while 1.cpp, and then we use GDB to debug it. So GDB while 1 list. And in this case, there are several things that we can test. We can put a breakpoint on line 6, so every time we get to line 6, including the repetition, it will stop. Okay, so we'll put a breakpoint on line 6 first. I'm not going to put a breakpoint on line 8 because if I can stop on line 6, if x is actually less than 5, it will single step to line 8 here. So there's no need to put a breakpoint on line 8. All right, so let's go ahead and run the program. This is the first time, okay? And you can see that we get to this part here. What is the value of x? Yep.
0.
0. This is before the first time we execute at line 8, and x was initialized to 0. So that's why x should be 0 at this point. And it is. So now if I single step, where am I going? No. We are already on line 6. If I single step, where am I going? Line 8. Okay? Line 8. Because x is 0, 0 is less than 5, so that means the condition is true. If the condition is true, I execute whatever statement is right after the condition. In this case, the open curly brace doesn't really count. We cannot single step an open curly brace. So the only statement that we can actually step on is on line 8. Okay, so single step, we are now on line 8. And then we single step again, where are we going?
Line 10.
Not line 10, this is a loop. It's not a conditional statement. We go back to line 6, okay? This part is unconditional, okay? Remember, this part is unconditional, which means, at the end of the action or the statement block that you specify after the condition of a while loop, you always go back to reevaluate the condition. So in this case, after line 8, we always go back to line 6. Now, as far as line 6 is concerned, it will go back to line 8 sometimes, it will go to line 10 sometimes, okay, depending on whether the condition is true or not. So we single step, we go back to line 6, this time x has a value of 1, single step, single step, single step, single step. Okay, now it's 3, 4, and where should we go this time? If I single step from line 6, where should we go? Okay, let me list the program again, just so that you know which code we are talking about. We are on line 6 right now. X has a value of 4. If I single step, where am I supposed to go?
8.
Still line 8, right? Because 4 is still less than 5. So single step, line 8, single step. This time x has a value of 5. If I single step, where am I going? Line 10, right? Because 5 is less than 5 is false. Okay, and if the condition is false, we get out of the conditional statement, and the statement after the conditional statement is line 10. Okay, so when we single step this time, sorry?
Shouldn't you have to go back to 6 to check that if it nice.
We're already on line 6 right now. We are currently on line 6 before we evaluate line 6.
Okay.
So when I single step, that means I will execute whatever code is on line 6, and then we'll determine where to go based on that condition. Because 5 is not less than 5, or 5 is less than 5 is false, that means we are going to get out of the loop. And the first statement out of the loop is line 10, so when I single step, it goes to line 10. And at that time, x would also have a value of 5, because checking the condition in this case does not change the value of x. We still doing okay so far with this code. All right. Let's mess around with this one a little bit. Okay, so we'll copy while 1 to say while 2. This time I'll change the program. I'll change just the way I initialize this code here. I'm going to say, well, let's say x starts with a value of 5 and see what happens to this program. So we'll go ahead and recompile the program in G++-E-O while 2. While 2.cpp and gdd while 2. List the program. Once again, I put a breakpoint on line 6. Yep, go ahead.
What does VIM stands for again?
VI improved, and VI itself stands for visual.
Okay, so basically we're creating a new project, or
I copy, the CP is copy, so I copy while1.cpp to while2.cpp. It's just a copy of the first one, and then Vim is just going to while2.cpp and change it.
Okay.
It's basically a copy, paste, and modify.
Okay.
All right, so I put a breakpoint on line 6. If I run the program, okay, it gets to line 6, okay, and right now x has a value of 5, and yet this is the first time we get to line 6. So if I single step here, where am I supposed to go? Line 10, exactly. Okay. In other words, in this case, I don't get to line 8 even once, which is exactly what you expect to do. I mean, this is called a pre-checking loop for a reason. You check the condition before you get into the body, before you have the possibility of getting into the loop. Are we still doing okay so far with this code here? Okay. If there are no questions, I'm going to combine what we have just learned here with something that we just talked about a little bit earlier in this class. Okay. So we'll go to, I'll just make a copy of this. So I'll copy while2.cpp to while3.cpp. And I think I can type this faster than most people can, right click and make a copy of a file and then change the name of the new file. What do you think? Maybe? Okay, so here's another way to do this. So I'm going to change this program back to 0 here, and I'll do something that's kind of funky. Take this out and put a x++ here. Okay. What do you think?
Add 1. Add 1 or something.
What adds what?
X++.
X++ is the post increment operator. So this is the program. This is it. Okay, this is the program. But I want to find out two things. Okay, first one is what is the value of x by the time we get to the return statement. Okay, and the second thing I want to ask is how many times are we going through the loop? Okay, so there are two questions here. Obviously, the answers can be, you can get to the answer just by running the program through GDB, right? But you should predict the answer first. Okay, you should, based on your understanding of the material for this class, predict what the answer should be, and then run the program through GDB to verify that your understanding is correct. There's nothing wrong with your understanding is off a little bit, and the program doesn't do what you're expecting it. Okay, because that's a chance for you to learn something, right? It's good that you discover that you might have misunderstood something early on in the class instead of later on in the class. Okay, so there's no problem at all if what you predict is not what the program is actually going to do in GDB. Okay, so what do you think? The first time we get to, okay, let me turn on line numbers here. The first time we get to line 6, x starts with a value of 0. Now because the plus is after x, it is a post increment operation. So in the first time we get to line 6, we are comparing 0 with 5. 0 is less than 5, but as a side effect, x gets incremented. So by the time we get to quote-unquote line 7 and 8, which is the body of the loop, which is empty in this case, x actually has a value of 1. Okay? So using that, if you just keep going, like, okay, so when we get back, x has a value of 1, we compare 1 to 5, 1 is less than 5 is true, but we also have a post increment, so by the time we get to line 7 and 8, again, x would have a value of 2, and so on. So using this, by the time we get to line 9, what would be the value of x? It would be 6 instead of 5. But how many times are we going through the loop here? In other words, if you have a way to count the number of times we get to line 7 and 8, how many times do we get to line 7 and 8? The first time, x had a value of 0 initially on line 6. The second time, x had a value of 1, 2, 3, 4. So we'll actually go through the loop exactly 5 times, just like in the previous program, just like in while1.cpp. The only thing is, by the time we get out of the loop, x doesn't have a value of 5. It has a value of 6. Okay, so let's go ahead and check it. Okay, so what I'll do is I'm going to put I will see if this works. Okay, I just put a semicolon here because it is the simplest statement that you can make. It's an empty statement, doesn't do a single thing. But I want to see if I can put a breakpoint on line 8, just so that we can count the number of times we get to line 8. See, sometimes I don't know how whether the compiler would do what I think it would do, because these are kind of like special cases. So we'll do a g++ -o while3 -g and while3.cpp and gdb while3 list. So this time I'll put a breakpoint on line 8 and see if it works. So run. Nope. Doesn't like it. It basically optimized the empty statement out of the whole thing. Okay, so I have another way to make a stupid, useless statement that doesn't do a single thing that the compiler may not like. Okay, well, it has to like this. Okay. What do you think of this statement here? Okay, first of all, is it dangerous? You know, Tach, don't do this. This is bad. No. Does it do anything useful? No. But it does give the debugger a chance to stop. That's all I'm trying to do here. Is I want to stop and count the number of times we get to this line here. So let's see if we can trick the compiler and say, yeah, let's go do this useless kind of thing. So let's see, gdb while 3. Put a breakpoint on line 8. Run. Nope, it's smart enough to bypass that too. It is really smart. Okay, but I just want to make sure of one thing. Okay, so we'll put this program, put a breakpoint on line 8, and then put a breakpoint on line 10. Run the program, print the value of x. Okay, it is 6, so we at least confirm that much. Yeah, I could do that. I'm still trying to trick the compiler. I'm getting obsessed with tricking the compiler to stop on a certain line just because I put something useless there. I wonder if the compiler can optimize this and say, that is still the same thing. Maybe it will, maybe it won't. We'll give it a try. Nope, it understands that. I suppose we can do a y here. I was hoping that I didn't have to do this. Yeah, this time it stops. Okay, so we want to count the number of times we get to this line before the program, is completed. So this is the first time, second, third, fourth, fifth, and the program is done. So it went through the loop exactly 5 times. But I was surprised how much work I had to do to trick the compiler and say, I just want to stop here. Okay, don't do anything useful. Stop. Can't do that easily. All right. So are there any questions about the while loop? Any questions? All right. Let's move on to the do while loop. Okay. So with the do while loop, let's start with. I'll just start with something new here. So this is do while one.cpp, and we have the usual template of the subroutine main index here. And we'll have something that looks almost exactly the same as last time, except this one is a do while loop. So we have do and then something, and then while x is, say, less than 5. Okay. Let's change it to x is 5. Okay. So we're explicitly saying, while x is not, sorry, take it back. While x is not 5, keep doing it. Okay. Go back and do it again. And what we're doing again and again is the same thing. X gets x plus 1. Okay. So by the time we get to return 0, what would be the value of x? We stay in the loop as long as x is different from 5. So if we ever get out of the loop, what should be the value of x? 5. Okay, very good. Okay, so we'll go ahead and run this program. G++ -e -o do while 1 -g So we'll put a breakpoint on line 8. Okay, and just run the program. Okay, this is the first time we get to line 8. What should be the value of x at this point? This is before we execute the statement on line 8. Should be 0. Okay, that's how we initialize the value of x. So print x, return 0, perfectly okay. Where am I going? Do I have a choice where to go from here? Is there an option for me to go to here sometimes and go to there some other times? Nope, don't have a choice. Okay, at the end of the operation in a do while loop, you evaluate the condition. You always do. So we always end up on line 10, which evaluates the expression. It kind of skips over that because it's it checks the condition already. So it goes back to line 6, and now we get back to line 8. The value of x should be 1 at this point. It's going to increase it by 1, and it will keep doing this. Okay, it's 4 this time. So what do you think it will do when I single step it? It's already 4. We are on line 8 at this point. So after line 8 executes, it becomes 5. But since I really cannot stop, on the while line, 5 equals to 5 is true. Excuse me, 5 is different from 5 is false, which means I'll get out of the post checking loop, and I should end up on line, I think 10. Okay, let's double check. Yeah, I would end up on line 11, which is the return statement. Okay, so we'll single step. And I was on line 6 before, but I wasn't on line 8, sorry. This time it will go to line 11. It wants to get a do first. It's just weird how it goes back first, because there's no condition to evaluate on line 6. But it does evaluate the condition first, and then we get to line 11, which is exiting the loop, and the value of x would be 5. Okay, it's just the way it's tracking it is a little bit weird, because it doesn't stop on line 10. Instead, to evaluate this condition, it goes to quote-unquote line 6 to evaluate that condition. Okay, so that's what this program does. Let's mess it up. So we'll copy do while 1.cpp to do while 2.cpp, and then you do while 2.cpp. I'll just change one line of this program. Change that to a 5. Now this one is very tricky because it's a it's doubly tricky in this case. So what do you think this program is going to do? Okay, well, forever is a long time. In this case, it will, okay, so this is, let me turn on the line numbers, then I can refer to the line numbers here. Okay, so on line 5, x already gets a value of 5, okay? So you might say, oh, okay, but the loop is we'll stay in the loop as long as x is not 5. So, but since x is 5 already, we'll just skip all the way to line 11 and we're all done. Well, it doesn't work that way because it's a post-checking loop, which means from line 5, it will get to line 8. So when it gets to line 8, x becomes 6. So by the time we evaluate the post condition on line 10, x is already 6. 6 does not equal to 5 is true. So we go back to line 8. X is updated to 7. We go to line 10 again. X is 7. 7 does not equal to 5 is true. And then 8, 9, 10, 11, and so on. So as far as the math goes, x will never become 5 again, and this becomes an infinite loop. Right? Okay, let's go ahead and do it. Let's go, turn this computer into a heater. G++-G-O, do while 2.cpp, and we'll go to GDB. Okay, so GDB do while 2. Actually, I'm not going to run it in GDB. I just run the program without GDB for now. And it's supposed to be an infinite loop, right? And it seems like it's an infinite loop. It'll take a while. the real question is, why is it coming back? You're supposed to stay in the infinite loop, but it's coming back.
Because you're the limit on the number of bits per x.
Yep. Because what happens when you add 1 to the most positive number as a whatever width you want to specify? What happens when you add 1 to it? Let's think about it. Let's think about it for a moment. Okay? And instead of using 32-bit, which is really long and takes a long time just to write it down, I'm going to use a 4-bit number. Okay, 4-bit number so I can get it. Okay, 0 as a 4-bit number is 0, 0, 0, 0. Okay, no big deal. We know that. 1 is 0, 0, 0, 1. 2 is 0, 0, 1, 0. 3 is 0, 0, 1, 1. Da 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 da. And then we go to with 7 bits, the largest positive value that we can represent is 2 to the power of 4 minus 1, which is 3 minus 1. So that's 7. Okay. So by the time we get to 7, it becomes 0, 1, 1, 1. Okay. But this is already the largest number that I can represent on the positive side. So what happens when I add 1 to it? Now, you have to add 1 to it in the binary form first, and then we'll figure out what it is. If you add 1 to 0, 1, 1, 1, you get 1, 0, 0, 0. But as a signed number, it is not representing 8. It's actually representing negative 8. And then the next one is 1, 0, 0, 1. It becomes negative 7. And then the next one is 1, 0, 1, 0. It is negative 6. And so on. Okay? The point is, it doesn't even matter how negative numbers are represented because it will keep rolling on until it gets to 1, 1, 1, 1, which represents negative 1. So now, if I add 1 to 1, 1, 1, 1, what do I get? I only got 4 bits. Okay? If you add 1 here, then we'll have carries all the way, and then it becomes what? It becomes 0, 0, 0, 0. Okay? It becomes 0, 0, 0, 0, and then back to 0, 0, 0, 1, and so on. In other words, with any fixed width integer representation, you either encounter a problem which is out of bound, okay? You're running out of values that you can represent, and it complains right away. That's what VB would do, okay? If you try to keep adding 1 to an integer, and it runs out of values to represent, it will give you a runtime error and just say that, well, we have an overflow issue here. You're trying to do some sort of math that where the value cannot be stored. But in this case, C and C++ does not give you the error. It will just quietly roll over and then keep going. So eventually, it will get back to 5. Go ahead.
Yeah, you answered it.
Oh, okay.
It gets back to 4.
Yeah, so eventually it will get back to 5, but but it will go through the entire thing, okay? So it go from 6, 7, 8, 9, all the way to 2 billion something, and it goes back to negative 2 billion something, back to 0, 1, 2, 3, 4, and then 5, and then it gets out of the loop. Yep.
So, with your example, you had it as an 8-bit number.
As a what?
As an 8-bit number or a 4-bit number.
Right.
And if you basically do a 60-bit, it'll still return. It'll just take that much longer to get back to that original number.
It's exponent to how much longer it will take. So with a 32-bit number, it takes significantly longer than 4 bits. Are there any questions about this, particular program? The representation of negative numbers is not really a big deal. It's just that it will get back to the original value, which does not make sense. Okay, if you're a math major, it should never come back, right? You can keep adding 1 to an integer, it gets to the next one. But in computer science, there's no infinite numbers when you represent integers. Okay, with 32 bits, you can only represent 4 billion something. Okay, we use half of those for negative numbers. We use half of those for non-negative numbers. So eventually, get back to 5, and then the loop exits. All right. Are there any questions about this particular sample program? How it is supposed to be an infinite loop, but it's not. So that's why I call this program. I said this program is doubly tricky because the first trick had to do with it is an infinite loop, because it doesn't look like an infinite loop, but it is an infinite loop. Then the second part is it's not exactly an infinite loop, it just goes a long way before it gets back and exits the loop. And nonetheless, it is a little bit tricky. So are there any questions about this particular sample program to illustrate, do while loops instead of while loops? No questions? All right. If there are no questions, we'll move on to a for loop. Well, we'll just go ahead and read through the notes here. As a post-checking loop, a do-while loop performs at least one iteration. I think I haven't illustrated that one yet. Yeah, so let's go ahead and illustrate that one. So I'm going to copy do while 2 to do while 3. And change this one. So we'll go ahead and say, okay, that will do. Let's change this so it's even more clear what we are talking about. Okay, there we go. So this is not an infinite loop anymore, because even if someone is to misunderstand how a post-checking loop works, it will still make sense that 8 is less than 5, so we're going to exit. Okay, but the point is we're not going to compare 8 to 5. We're going to compare 9 to 5. Okay, because it's a post-checking loop, which means we have to go through line 8 at least once. So the first line to execute is line 5. X gets a value of 8. And then we go to line 8. Because it's a post-checking loop, you have to perform this statement first. So line 8 is going to change X to 9. So by the time we get to line 10, X already has a value of 9. But 9 is less than 5 is still false. So we will still get out of the loop. But the point is we got to line 8 at least once in this case. We'll double check to make sure that is really the case. So G++ -G-O do while 3, do while 3 CP. Put a breakpoint on, well, I'm brave, I put a breakpoint on line 8. And now we're on line 8. X should have a value of 8 at this point, because that's coming from line 5. With single step, it says it's going back to line 6. It's actually on line 10 to evaluate the expression, and the expression should come out as false, and then we should continue execution on line 11 after this, and that's exactly what it does. And if you print the value of X, it is 9. Now based on a program like this, if the value of 9, that means we have gone through line 8 exactly once, because that's the only line that can change the value of X. Is that making any sense? X got initialized to 8, and somehow it's 9 at this point, and the only other line that can change the value of X is line 8. So this is proof that we have gone through line 8 exactly once. All right. Are there any other questions? No questions? All right. We can move on to the for loop. The for loop is actually a very short slide. Yep, go ahead.
Roll sheet.
I forgot to bring my row sheet folder, so there's no row taking today. Oh, I know what. You guys can log into Moodle, and I'll use it. Use that as row purposes. Except for people without a computer. You can still log in using your cell phone if you had a smartphone. Okay. I can see everybody has a mobile device, so that's good. So you have to log into the class, okay? Not just Moodle, but click into this class here. Okay, so here's a for loop. A for loop looks complicated, but it's not, okay? The way a for loop works is, this is the format. Okay, look at the syntax part here. That's the syntax. So you start with for, you have to spell out, the way it is. You have an open parenthesis, and then we have a closed parenthesis. I'll explain the stuff in the middle next. And then we have a single statement as the quote-unquote body of a for loop. Okay, so once again, I use a block statement here because I want to encourage you guys to use a block statement. Wherever you need to specify just one single statement, use a block statement because that way it's easy to expand it without having to without worrying that you might run into problems. What is interesting about a for loop is what is inside the parentheses. Inside the parentheses, we have one single statement that is the initialization of everything that is related to this loop here. And then we have one single expression that is the Boolean expression. So if this expression is true, we stay in the loop. If this expression is false, then we get out of the loop. And then we have the third component inside the parentheses. It's called a post operation. And the post operation is also a single expression. Okay, so we have three expressions inside the parentheses: the initialization, the condition to stay in the loop, and then the post operation. The post operation is, as the name implies, whatever we do at the end of each iteration, that will be performed. So the way it works is you can use a while loop to do exactly the same thing. So I'm going to show you both the for loop format and also the while loop format. So what you can do, with a while loop is you put the initialization before the while, and in the for loop we put it here. Expression goes to the same place. It is basically, if it is non-zero, you stay in the loop. If it is zero, you get out of the loop. And post is here if you turn it into a while format. It is the post operation. So you have to be done with body before you perform post in the while loop format. But in a for format, you put it here. In other words, a for loop is really basically the same thing as a while loop, except the components are put into different places. The reason why people use a for loop instead of just using a while loop and do it this way is because in a for loop, you are always reminded of, okay, what do we need to do to initialize everything to get ready for the loop, okay? You're always reminded, okay, what do we need to do after each iteration? These are the post operations that we have to do at the end of each iteration. In other words, what it does is to localize visually these three components: what to initialize, what to check, and what to do after each iteration, because these three expressions should be related. Am I making any sense here? How you get started with a loop, what to check for each iteration, and what to do after each iteration, they should be related. They should involve the same variables, or at least some of the same variables. And that's why in a for loop, these things are basically right next to each other. It's easier to see it. If you do it the opposite way, the other way, over here, if you have a really long body, let's say 50 lines, then it becomes really difficult to see the post operation. But the post operation should have a very close relationship with the expression here, because after all, you have to do something to change the expression so that it will become false eventually. So the for loop is a handy feature so that you can visualize and see all the variables that are related on one single line, and then the body can just refer to one of the variables involved and do whatever it needs to do. But it has nothing to do with controlling when the loop exits. So are we still doing okay so far with the concept of a for loop? Okay, it's really a shorthand of a while loop, but it does make it easier to track and debug. Any questions? Yep.
Can you make an example like you did with for other loops?
Absolutely.
Please?
Absolutely. So let's go ahead and write a simple program, as a for loop, and then we'll change it to a while loop format. So let's see. In fact, I can do something even a little bit fancy. So we'll do a for1.cpp, and this time I'm going to include stdio. So I'm going to print some numbers here. And in main, let's say we have two integers x and y, and I'll do it using the while format first, and then we'll switch to the for format. So x gets initialized to 0, y gets initialized to 100, and we say while x is less than 5, we stay in this loop here. first thing we do, the only thing that I really want to do is to print the value of x and y for each iteration. So we say %d, okay, x equals %d, y equals %d, x and y here. I'll explain all of this stuff later. There is a section, a topic that talks about printf, C in, C out. So don't worry. All this does is to say x equals whatever number x is, and y equals whatever number y is. Okay, that's all it does. Okay, that's not the main point of this particular sample program. And then after this, I have x gets x plus 1. So x is incrementing, and y is decrementing, like so. And then we have return 0 at the end of here. So if you just look at this code here, other than the printf line, which is a little bit cryptic, we're just basically printing the values of x and y on the screen. So this program should print x equals 0, y equals 100 on the first line, and then we'll print x equals 1, y equals 99. The last line it should print is x equals 4, and y equals 96. Okay, it will print 5 lines, and then the whole program will exit, and that's all it should do. Okay, so let's go ahead and run it and make sure that that's what the program is supposed to do. It does what it's supposed to. Okay, -o 4141.cpp, and I'll just run it without the debugger, and that's exactly what it does. Cool. So the next thing we want to do is to turn it into a for loop using the stuff that we just talked about. So we cp 41.cpp to 42.cpp. Now we want to turn it into a for loop. Okay. So to turn this into a for loop, we're going to do this. Okay, we'll do it this way. Nope. There we go, side by side. All right. So on the left-hand side, we have the original program. On the right-hand side is something that is equivalent to the original program. So I'm going to change the program so it becomes, so it would use a for loop. Okay. So I'm going to remove everything except for that part here, and I'll turn this into a for loop. And just the usual thing that I do is, I will do the structure first, and then I go back in and specify what is supposed to be, at a certain place. All right. The first part of a for loop, or the first part of the expressions inside the parentheses, is the initialization. But I can only have one expression, but I got 2 variables to initialize. Well, we have a mechanism to make it work. What mechanism, or what punctuation should I use to make this work? Comma, exactly. So a comma is a statement, or is an expression separator. So now I can look at x equals y as one expression, not a statement, as an expression, and look at y equals 100 as another expression, and then use a comma to combine these two and say that, oh, you know what, we have one expression now. Okay, it's just one compound expression using the comma as a separator. Okay. The condition is the second item here, and the condition, I'll keep the same thing. X is less than 5 is the condition. And now we have post operation, right? Whatever we do after each iteration is the post operation. So the post operation, according to the left-hand side, is we want to add one to x, we want to add one to y.
X plus.
Well, I can use the way it is. X equals x plus 1, comma y equals y minus 1. I can do exactly that because the assignment operation is an expression. So I can use a comma to separate those two expressions. But the whole reason why we use C and C++ is for efficiency, right? For density of the code. So in this case, you know what? The other way to say this, which is far more common than the way that I expressed earlier, is just to say increment x, increment y. In this case, whether you use pre-decrement or post-decrement, or y is decremented. There we go. So in this case, whether you use post or pre doesn't really matter, because nobody cares about the value of the expression itself. Plus plus x and x plus plus, they have the same side effect of adding 1 to x. It's just that one returns the value of x after the increment, and one returns the value of x before the increment. But nobody cares here about the value of the expression itself, so whether you use x plus plus or plus plus x doesn't make a difference. Is that okay so far? Why it doesn't make any difference here? Because nobody is referring to do the value of the expression. We only care about the side effect of the expression of adding 1 to x. As long as it gets it done, nobody cares about the expression itself. All right. So you can see how this works. We have the initialization, the condition to stay in the loop, and the post operation all on the same line. So it makes it easier to visualize and say, okay, what do we do to get this loop ready to run? How do we stay in the loop, or how do we get out of the loop? That's just the flip side of that question. And also, what do we do at the end of each iteration so that eventually x is not going to be less than 5? So we just make it very easy to see they're all on the same line. But does the program do really the same thing? Well, let's find out. So we'll say g++ -042 -g42.cpp. I'm just going to run the program without the debugger, and you can see that it does exactly the same thing. Well, it's about the same thing, but it's not exactly the same thing for the same reason that we have talked about before. Yep. Now, this time they are really, really exactly the same. There's no difference between these two code. Right. Any questions about about a for loop, or any type of loops that we talked about today?
I didn't understand when it was, I think it was x plus plus was less than 5. How it ended up being 6, not 5.
It uses the value of x before the increment for the comparison, but it will add 1 to x also. It's just that it's not using the value of 6 for the comparison, it's using the value of 5 for comparing, and then it adds 1 to x. So it still has a side effect of adding 1 to x, even though x is less than 5 is false. All right. So we are pretty much done with loops, conditional statements, conditions, and stuff like that. And then I forgot one thing that's important. I forgot about lazy evaluation or short-circuited evaluation of logical expressions. Okay, so that's easy to explain. We got enough time to explain that part. I'm going to type up the notes later, but I will talk about the concept first. Okay. So let's go ahead and take a look at some examples first, and then we'll talk about it. In fact, we'll write some programs to test it. Okay, so we'll do it like. Okay, it's called short-circuited evaluation, and we'll use these two. So we have x and y again. We'll say x gets initialized to 0, y gets initialized to 100, just like last time, except this time in the loop here, we have, we say x is less than 5, and y minus minus is greater than 0. There we go. And inside the loop here, we just do a printf. So we'll print x equals to its current value, y equals to its current value, \n is end of line, so that's the line feed character, and then we specify x and y to fill in the the placeholders of %ds, and that's it. That's the entire program. Okay, so let's take a look. The line numbers. So line 9 is doing what the other program does. It prints x equals whatever the value of x is, comma, y equals to whatever the value of y is, line feed to open a new line. Okay, so this program is not that much different from the previous one. The only part that is different is the condition of the while loop is now a conjunction. Okay, it says x is less than 5 and y minus y post decrement is greater than 0. And most of you probably will spot this right away and say, oh, but x will become 5 long before y is not greater than 0, right? I mean, y started off with, say, what 100, okay? 100, 99, 98, 97, 96, and, okay, we are going to get out of the loop because of x anyway. But the question is, what do you think is the value of, oh, I forgot one thing. I forgot to change the value of x. Okay, so we'll say x gets x plus 1 here, because otherwise it will still exit, but it won't do the same. It won't demonstrate what I want to demonstrate. Okay, so x is going to be incrementing inside the loop body here. So x goes from 0, 1, 2, 3, 4, and then gets to 5, right? When x gets to 5, 5 is less than 5 is already false. According to conjunction, if one side is false already, the whole thing is false. But the question is it going to evaluate the right-hand side when the left-hand side is already false?
No.
That is the question. And according to the name short-circuited evaluation, it implies that it does not, right? So can we actually test it and see whether the right-hand side is evaluated or not? Okay. What do you think? If the right-hand side is evaluated, what would be the value of y when the program exits, when we get to the return statement? You'll get to line 95, right? Because it will just have that one extra decrement. If the right hand side does not get evaluated when the left hand side is already false, then y should end up with a value of 96. Is that making any sense? Okay, so that's our indicator. Okay, that's our indicator of whether short-circuit evaluation is really being used here or not. Okay, so let's go ahead and test this program. G++. Sorry?
You forgot the decrement y.
I did it in the expression itself. Y is already being decremented here. Okay. So we'll go ahead and test this out. Short-circuited. Shouldn't pick the long name like that. Complaints about printf was not declared. Oh, okay. I forgot to do a pound include stdio.h. Go. GDB short-circuited. Nope. That one does not require the // list. Let's see, where am I going to stop? Let's stop on line 14, because the only thing I want to know is whether y is 96 or 95. Okay, so we are now putting a breakpoint on line 14, which is after the loop. Run the program. It prints 99, 98. Okay, so now the question is whether it's 95 or 94. I forgot about the decrementing before the printing part. Okay, so do you think it's 95 or do you think it's 94? If short-circuited evaluation works, it should be 95. If short-circuited evaluation does not work, then it will always evaluate the right-hand side, and then y should end up with a value of 94. So the question is y 95 or 94? And it's 95 because of short-circuited evaluation. Okay, let's go back to the program and just let me re-explain what it is. So what's happening here is when the left-hand side is false. Now with a conjunction, if at least one side is false, the entire thing is guaranteed to be false, right? So if you were to be as lazy as possible and say, I'm not going to do some extra work when I don't have to, then you will say, oh, x is less than 5 is false because x has a value of 5 already. If you want to be as lazy as possible, then you would say that, forget the right-hand side. I'm not going to evaluate that. because the entire expression, the entire conjunction expression has to be false already. Why do I want to bother with the right-hand side? And that's exactly the attitude of G++. Okay, it doesn't do any extra work unless it has to. Okay, and this is called lazy evaluation. It's also called short-circuited evaluation. When one side is guaranteeing the result of the entire expression, it doesn't bother with the other side. Now, the next question is, well, according to a math class, conjunction is supposed to be commutative. Commutative means, it can swap the sides, right? X and Y is the same thing as Y and X. So how do we guarantee that which side is going to be evaluated first to decide which other side does not get evaluated? Well, in this case, the not G++, but the C++ standard specifies that in the case of a conjunction, it is always evaluated from left to right. In other words, in this particular case, it is guaranteed that you evaluate x is less than 5 first. And if x is less than 5 is false, then you don't bother to evaluate the other side. Are we okay so far with that concept? Now, this will become important later on. Okay, by the time we get to arrays, this is going to be a very, very important feature, because without short-circuited evaluation, you actually have to make the program more complicated to accomplish certain things that we want to do. At this point, it doesn't seem very useful. It's like, whatever. But later on, when we get to arrays, you will start to see that array bound checking is really, really helpful to have, short-circuited evaluation. Okay, if you want to search in an array, if you want to do some processing in an array, it really helps to have short-circuited evaluation. I will type the notes up, for short-circuited evaluation. I kind of forgot about this, but I will type it up. But the demonstration is done already. I'm just retroactively typing up the text for this particular topic. I will see you guys next Monday. I'm not going to be here on Wednesday. I'll be over at Cal Expo, talking to a lot of high school students, for Korea GPS. So we'll meet again on next Monday, not Wednesday. All right, have a nice weekend. It feels kind of strange to say have a nice weekend on a Monday.
Wednesday there's going to be no class or what?
No class on Wednesday.
Nice.
Yep.